Welcome to QuexBook Learning, and right now, let's have the continuation for our discussion about the limit laws. And for the product law, it states that for the limit of the function that involves the product of two or more factors, we can just take the limit of each factor and then multiply the results together after. But given that the limit for these terms exist. Okay, so let's have our first example. We have the limit of 5x as x approaches to 3. So here we have two factors, the 5 and the x. Let's take the limit of these factors and then multiply the results later. So we'll be having the limit of 5 as x approaches to 3 times the limit of x as x approaches to 3. The limit of 5 as x approaches to 3, according to our constant law, the limit of a constant is the same value of that constant. So the limit for this function is 5. And for the other factor, we have the limit of x as x approaches to 3. Now, according to our identity law, that the limit of x as x approaches to a certain number is just going to be equal to that number the x is approaching. So the limit for this function is 3. And multiplying 5 and 3, we will be having 15. Therefore, the limit for this function is 15. Now for our next example, let's evaluate the limit of x times x plus 1 as x approaches to 2. The two factors we have here is x and x plus 1. Let's try to take the limit of each factor, then multiply the results later. So we have the limit of x as x approaches to 2 multiplied by the limit of x plus 1 as x approaches to 2. Evaluating the limit of x as x approaches to 2, we have 2. Now, evaluating the limit of x plus 1 as x approaches to 2, we can break it down and apply the addition law. So we will be having the limit of x as x approaches to 2 plus the limit of 1 as x approaches to 2. Now, the limit of x as x approaches to 2 is 2. And the limit of 1 as x approaches to 2 is 1. Adding up 2 and 1, we will be having 3. Now, multiplying 3 by 2 is 6. Therefore, the limit of this function is 6. Next, we have the quotient rule. And this law tells us that we can simplify the limit of the numerator and denominator separately as long as we don't get any zero in the denominator and then divide it if possible. But given that the limit for these terms exist and the limit for our denominator should not be equal to 0. For example, we have the limit of 15 over x as x approaches to 3. Evaluating the limit for both numerator and denominator, we have the limit of 15 as x approaches to 3 over the limit of x as x approaches to 3. The limit of 15 as x approaches to 3 is 15. And the limit of x as x approaches to 3 is 3. Dividing 15 and 3, we will have 5. Therefore, the limit of this function is 5. Next, we have the constant multiple law. And it states that if your function has a coefficient, you can take the limit of the function first and then multiply the coefficient after. But again, given that the limit for this term exists. So let's have our first example. Evaluate the limit of 2x as x approaches to 4. Take out the coefficient, which is 2, and then evaluate the function first. So we'll be having 2 times the limit of x as x approaches to 4. Evaluating the limit of x as x approaches to 4 is 4. And multiplying it by 2 is 8. So the limit of this function is 8. So let's try another example. We have the limit of 5x as x approaches to 2. Take out 5 and then evaluate the limit of the remaining function. So the limit of x as x approaches to 2 is 2. Multiplying it by 5, we will be having 10. Therefore, the limit of this function is 10. So next we have the power law. And when taking limits with exponent, you can take the limit of the function first and then apply the exponent later. But again, given that the limit for this function exists. For example, we have the limit of x cubed as x approaches to 4. Let's take out first our exponent and then evaluate the limit. So we'll be having the limit of x as x approaches to 4 raised to 3. Evaluating the limit of x as x approaches to 4 is 4. Now applying the exponent, we'll be having 4 raised to 3 or 4 cubed, which is equal to 64. So therefore, the limit of this function is 64. Let's have another example. Find the limit of x plus 1 squared as x approaches to 2. Taking out the exponent and evaluating the function, we will be having the limit of x plus 1 as x approaches to 2 raised to 2. So applying the addition rule, we have the limit of x as x approaches to 2 plus the limit of 1 as x approaches to 2. Evaluating the limit of x as x approaches to 2, we will have 2. And evaluating the limit of 1 as x approaches to 2 is 1. Adding up 2 and 1, we'll be having 3. Now applying the exponent, we have 3 squared, which is 9. Therefore, the limit for this function is 9. For the last law that we will be discussing, it's the root law. And for root functions, we can find the limit of the inside function first and then apply the root later. But we have certain conditions for this. First, the limit for this term should exist and the limit for this function should be greater than or equal to 0, meaning no negative values. For example, we have the limit of the square root of x plus 14 as x approaches to 2. Applying the root law, let's evaluate the limit of the function inside the square root first. So we'll be having the limit of x plus 14 as x approaches to 2. We can use the addition law here. So we will be having the limit of x as x approaches to 2 plus the limit of 14 as x approaches to 2. Evaluating the limit of x as x approaches to 2 is 2, while the limit of 14 as x approaches to 2 is 14. Now, adding up 14 and 2, we will be having 16. Applying now the root, so solving for the square root of 16 is 4. Therefore, the limit of this function is 4. And that's it for our limit laws. So if you enjoyed this video, please give us a thumbs up and do subscribe to our YouTube channel. So see you on our next learning videos and enjoy learning.